Hello, I am the overdressed mathematician, and today we're looking at this problem right here. We got two semicircles, and we have a secant that's parallel to this diameter right here. And that's length of 16. And the question we have, and what we would like to get an answer for, is what is this area, this blue area right here? And at first, I don't know. So I'd have you pause the video right now, check to see if you can do it yourself, and then we'll get back here, see if you got it right, see what you thought. Okay. Bam. I hope you're back. Okay, so how we want to solve this is, let's first look at this 16 here. This is a secant. This isn't just the diameter. So if it was the diameter, we could half it, pi r squared, get the area, whatever. But this is a secant. So let's just, when we only really have 1 or 2 units, we want to try to get some variables in here. So let's just define a couple variables. So let's first get the radius of this big circle here. We'll call it big R. That's going to be the radius of that. And then let's also get the radius of this right here. We'll call it little r. Okay. We're looking for this, the area of this minus the area of this. So what's the area of that? Well, that's pi big R squared. But since it's a semicircle, we just do half. Minus half pi little r squared. So the area of the big one subtracted the area of the little one. And we can take out half pi here, so that's also just equal to half pi times big R squared minus little r squared. Okay, doing good. Let's keep going. Let's look at some things. So we are looking for this, and then this is going to be the final answer to the problem, but we need to get those variables out of here. So let's try to make a little triangle here, because triangles are a lot easier to deal with. So let's get just one right here at this is going to be this side. The height will be, of course, little r, because these are parallel lines. So this height's going to be little r. This leg right here is going to be 8, because it's half the secant. And this one right here. So we have a right triangle here. 2 legs, base, leg 1 is r, leg 2 is 8. This will be a big R, because this is just a radius. So it goes around all the things from the midpoint to that outside right there. That's going to be the radius. Okay, since this is a right triangle, we can apply the Pythagorean theorem, and we can say that little r squared plus 8 squared is equal to big R squared. Okay, that's pretty good. Now, we're looking for that. That's pretty similar. So let's subtract little r squared on both sides, and we get big R squared minus little r squared is equal to 8 squared. And let's look at that. Same thing. So we want to apply 8 squared into there. So half pi times 8 squared. What is 8 squared? That's just 64. Okay. Let's apply that inside. That's going to be 32 pi. And that will be our final answer. There's no units given, so you don't have to put units in, but if you wanted to be specific, you could put 32 pi units squared, since we know it's a 2-dimensional figure. Okay, thanks for watching. This is my first video, actually, so if you'd like to see some more, I don't know, maybe subscribe. Okay, thank you. See you next time.